constantly. So let's try to hear what we will produce. Isn't that great? What I have here is not Commodore 64, it's Acorn Electron, and it's amazing little computer, a baby brother of a big BBC Micro. Now, the reason why this machine exists is the same reason why Commodore TED series exists, and that is to beat ZX Spectrum. But as we already know this, neither of this machine actually succeed in their quest. Nevertheless, this Electron is fascinating little machine. The heart of this computer is 6502 CPU running at 2 MHz. Now, that doesn't mean that it's twice as fast than Commodore 64, because this is, after all, a budget machine, and there were lots of cuts made, and one of them is that data bus speed is only 1 MHz, and all others problems that they had, so it's not really fast. Nevertheless, we have BBC Basic on it, operating system 1.0, and we have 32 kilobytes of RAM. There are no joystick ports, only video outputs on this side and cassette interface. The sound is available in the form of a speaker built in the inside of the machine, and on the back we have an expansion port and that's all. So, but I must confess that I'm absolutely fan of Acorn versus Sinclair story and all this time period, so I would highly recommend you to watch Microman movie, and also if you want to more in-depth story of and background in the history of this machine, I will highly recommend that you watch Acorn Electron Part 1 and 2 from the Retro Shack, and that will give you more in detailed information about this machine. Now, this here is the main adapter for this machine. And this here is the power supply board that usually sits inside the case of this machine, like this. So the reason why this is outside and not inside the machine is because I'm working on this, and how it's possible that this machine is working without this even connected. I will leave this for the video where I'm going to try to repair this board and try to get it back inside and make it functional once more. But today we will take a look at the BBC Basic and general usability of this little machine. Although it would be more fair to compare this machine with Commodore Plus 4 or C16, but I will compare it with Commodore 64. The reason why is because I think it would be amazing if Commodore 64 had some of the features that this machine has. Not all of them, but some of them. So let's begin. When we power on the machine, this is the message that is shown on the screen: Acorn Electron Basic. The keyboard of this machine is absolutely fantastic. It's really great type, really robust. It does have more ringing sound than on Commodore 64, but it's absolutely great. The only downside is it doesn't have anything to do with this keyboard, but just I was kind of used to have a backspace up here, but this key is actually to reset the whole machine, so the backspace is actually down here, so it takes a little bit time to get used to it once you transfer from Commodore 64. Now let's try to type some program. Test. And it runs just fine. Very nice. Now, what if we want to change our program? Now, I was kind of used for Commodore 64 user interface that I'm able to go all over the screen and just change whatever I want. So this is not the case here. We have just little small cursor that we can move along the whole screen, but we cannot change anything. What we actually must do is use this copy key, and when we press this, it will just copy whatever was under this small cursor down here, and if we keep on pressing it, it will just make a copy of this entire row. And changes you made, what changes do you want to make, you can make it here and continue to copy, and then press return, and we change our line in BASIC. So if we run it, this is the new message. Now, what the next thing that we that would be absolutely amazing if Commodore 64 has, and that is full support for hex numbers in BASIC. Now, let us try to type some loop for I equals hex 0 to hex 10. Let's print hex I 30 next I, and let's run it, and there we have our little loop that prints hex numbers from 0 to 10. The next thing is full support for the if statements, so if then else is absolutely supported. So let's say in line number 25, if I equals 5, then print great 5. Let's print 5, else print none, and let's run it. So it's maybe not the best example, but you see here when it was 5, print 5, everything else is just none. So that's absolutely great. The next we have some additional loops that we are able to use here. One of them is repeat until. So let us expand a little bit our program. So in line 5, let's put repeat, and on line 40 until false. Now let's list. Now this should give us infinitive loop where our for loop from 0 to 10 hex will be repeated infinite number of times. So let's test it, and here we go. The next thing that we have are the functions, and that's something very, very useful here. Now first let's try to get rid of this line 5, line 40, we don't need that, and we will just add line 40 as end. Okay, so let's start to write our function. So we will go, let's say, line 100, and we will define function, and we will call it F1. And what we need to do next is define argument, and that will be some number n. That's okay. And the next thing that we will do here is set equal. That means that we are returning n multiple by 2. So this is the way we define a function, and the way we call it, we will do it on the line 20. So line 20 will be print, and we will call our function F1 and I. Okay, let's list it first. Okay, so we have our loop, we have on line 20 print, and then we call a function. 40 is the end of the main program, and we have definition of our function on line 100 and 110. So let's run it. There you go. So this is simple function that just multiply our number I with 2 and return it back, and we print it on the screen. The next thing that this little computer has is several graphical modes, and to be exact, it's 7 of them. They're not super fancy, but one of them, two of them is absolutely fantastic. If Commodore 64 has this, it would be amazing. Let's see mode 0. And like you see, this mode is high graphic definition mode, and it's 80 columns mode. So this is absolutely fantastic. This little machine has 80 columns mode, and okay, it's not all great. So there are only 2 available colors here. That is this and black. The only other option that we have is on mode 3, where is this is also 80 column mode, but it's just text. There is no graphic, that we cannot do any graphics here. But there are others modes available. So let me load some graphical programs and try to draw something on the screen. Okay, so we have some small program here that draws some lines on the screen, nothing special. So let's try it first in mode 0, that's high resolution mode. And like you see, there's white lines and black lines, but it's looking very nice. So let's try to let's make it more readable. Sorry. Okay, so let's try to change line 10 to mode let's say mode 2. This mode has more available colors. So it has 8 colors and plus 8, I believe, blinking ones. So let's try to change our random color here. So copy, and 8. Copy, delete, shift this. Okay, list. Okay. Mode 2. 8 random colors and run. So there we have it. As you can see, several of them are blinking. Yeah. Let's back to mode 1 and list our program. So the next thing that that I'm going to show you is a little bit of sound. It's nothing fancy. If we talk about sound, the Commodore 64 has way much better sound than this machine, but let's try anyway. Now what we have here is just a small program that uses gets a random number from 0 to 255 and just add it as a pitch in the sound command and just repeat it constantly. So let's try to hear what we will produce. Isn't that great? Okay. To change text color, we use command color, and because we are in mode 1, we have 4 available colors, so let's choose yellow. And now we have text in yellow, and if we want to change background color of the text, not on the screen, we can choose the same command again and select one of the codes for the background color. So let's say that we want something like red, and here we go. Now if we want something that is more like Commodore 64, to change color from the all background, not just text that we are typing, the Acorn Electron has or BBC Basic has something called VDU command. So VDU is used for lots of stuffs, and one of these is changing the background color. So if we want to change our color, just one moment, it was 0, right? So are we in mode 1? Okay, let's try again with you. 04. Okay, so this is one of the ways how to change background color of the whole screen. It does look nice. And if you think that I forgot about peek and poke commands from Commodore 64, well, I didn't. And there is any such commands on Acorn Electron. But there is something that is equally or even more powerful than that. So that something is called address pointers. So we are able to point at specific address in the memory, at specific location, and because this is because BASIC has hexadecimal support natively, this is absolutely user friendly. And if we combine these address pointers with other operators and other commands, we can construct even more powerful commands than just picks and pokes. So this is one example that we want to read 1 byte from a specific memory address. We will do print, then we will use question mark, and then simply write a memory address in hex value 1000, and this is the current value that is at that specific location. So if we want to have a result in hex, then we will use tilde and then all the rest of it. And so what is written in this memory location is dd. If we want to write something to this location, we can simply use same logic. So we are going to point at this memory location 1000, and we are going to write some other new value. So like, for example, AA. Just one moment, we need to specify that is hex value. So we will write AA. We did it. Now let's try to read one more time. So we will repeat this command, and there we go, we have AA. Now that's not all. We can also this is just writing single byte and reading single byte. We can do 4 bytes in a single read. So we can write 4 bytes, and we can also write strings, and that's up to 256 bytes in length. So for example, if I want to write some string at this location, what I would do is use $sign or string sign, and then again specify the location 1000, and then equal simple text. And now we saved the string and this location. So let's try to read it. So what we do is print, and again $sign and location that we want, and here it is, our text is back. So really powerful tool, absolutely fantastic, and simply because the hex numbers are just natively supported, it's absolutely great for this application. The last thing that I would like to do is run Noels speeds test, and that is just a little basic program that Noel RetroLab channel used to benchmark speed of BASIC on different platforms. So we have a small basic program with 2 for loops, and we will just measure a time that needed to complete the task. So let's begin. Run. And we are done. Wow, 26 seconds. That's really fast. And that places us alongside with Amstrad CPC. And we are faster even than Commodore 64, at least in BASIC. So that's all for today, and hope to see you in the next episode. Thank you and goodbye.